Hello everyone, this is Mr. Crozier. I want to give you some more examples with operations with complex number. Remember, complex numbers are numbers that have a real part and an imaginary part. And it could be like 5 plus 2i, or it could be 0 plus 3i, or it could be 5 plus 0i. So sometimes you don't have a part. We don't have a real part here, but we have an imaginary part. And here we have a real part but no imaginary part, but they're all complex because they can be written in the form a plus bi. So complex numbers. Alright, so here we go. Put them in standard form, which means convert them into just this. And this looks good except for we don't want i's mixed with this, so we gotta somehow simplify this. And remember our rule, I is the square root of -1 and I squared is -1. So I squared, this is a -1, so that's gone. And -1 times 4 is 4 minus 3i. And there you go, a plus bi. And we could write it like that, just as long as we know the a is positive and the b is negative. Alright, what do we have here? Well, this isn't good, and this isn't good. Let's go ahead and clean this up. And this is -10i plus square root of 25 is 5, but with a negative it's 5i. So now I'm going to put these two together, and I just have a -5i. Again, there is no real part. We could write it as 0 plus a -5i, which is just as good, just as long as we know there's no real part. There's a -5 here. Either one of those would be fine. Again, same thing here. Root 20, isn't that 4 times 5 with an I, and 2 roots of 5i. And again, there is no real part. There is no real part, but this is the imaginary part. 20 becomes 2 roots of 5. Alright, operations. Just putting stuff together. 3 minus 8 is -5. 2 minus a -5. Make sure you distribute that in there. That would be 2 plus 5 would be 7i. And again, try and put them in this form, a plus bi. We have to distribute. This times this is 6. This times this is -6i. And that is plus 14i. And that is a minus 14i squared. Some simplification here. I squared is 1, or -1, so that's going to make that positive. These can go together to make, what is that, 8i, and these can go together to make 20. Alright, working down here, if you see something being squared, you can't distribute that in there. That does not work. You must write it twice and then FOIL it. Let's see if we can't FOIL this faster. First ones are 36. The last ones are a positive I squared. And that's a -6i and a -6i and -12i. So if you can learn to FOIL like that, first ones, last ones, outsides and insides, it'll save you some time. What does this become? Well, I squared is a -1, so that makes it -1. 36 minus 1 is 35, minus 12 i's. What's wrong with this fraction here? 5 divided by I, we don't leave i's in the denominator. Just like we wouldn't leave this here, we would multiply it by root 3. We're going to do the same thing. We're going to multiply it by I. In the numerator I have 5i. In the denominator I have, what is I times I? I times I is -1. So it's a -5i. Alright, we don't leave i's down here, but if you multiply this by I, just I, it'll fix that, but it'll put the I right there, and we don't want that. So we multiply it by its conjugate. And if you do this, it will fix everything. So let's go ahead and do the top. 2 times, let's do the first ones. First ones are 12. Last ones are plus 3i squared. And this is a 6 and a 6, so 12i in the middle. Alright, on the bottom, 636 in the front. Negative times a positive is a negative. 3 times 3 is 9. I times I is I squared. And the reason why we do this is the middles cancel out. We have 18i and a negative 18i. That's nothing. There's nothing in the middle. And look what this does. I squared is negative 1. Changes it to positive. We have 45 over, what do we have up here? Again, I squared is negative 1. So we have 12 minus 3 is 9 plus 12i. So now we just divided. Now we can, everything here can be divided by 3, so we can simplify it one step further. Divide the top by 3 and the bottom by 3. That's 3 plus 4i over 15, and that is simplified. We started way back here and we said this complex number divided by this complex number is this complex number. But again, look, there are no i's in the denominator, so we're safe. Alright, on this one, just to conjugate again, multiply it by plus the second term. Watch what happens. The first ones are 25. The last ones are minus 4i squared. And the middles are a positive 10 and a negative 10. There is no middle. That's a negative 1, and it's 29. Multiplying it by the conjugate eliminates this term. Alright, and you do have to do some work with roots, but we can figure that out. Plus root 3i. Negative times a negative is a positive 64. The middles are going to cancel out, right? So at the end, I'm going to have a minus root 3 times root 3 is 3i squared. I squared is negative 167. All right, these are the main things we need to be able to do with complex numbers. Remember, complex has an imaginary part and a real part. Sometimes it only has one part, but we can do all the math the same. All right, hope this helps.